Yes, how are you guys? How are you?
Okay, hello.
Yes.
Hello.
Yes, mwalimu.
Hello.
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 Last day.
Yes, mwalimu.
Connection is unstable. Okay. Hello.
Yes, we are able to get you, mwalimu.
Hello.
Muted.
Are you able to get, Mr. MBALUKA?
Yes.
But it is like...
Okay, good evening.
Yes, good evening to you, sir.
Good evening, teacher. Yes. Zima text zinaingia. Cha.
Steve.
Yes, Mr. MBALUKA.
Mnanipata kweli?
Tunakupata vizuri.
Sasa hivi mnanipata?
Yes, we can get you, sir.
Okay. Yeah, because I'm not able to hear you when I'm putting the mic. I want to see if with the mic you're able to see me. Now mnanipata kweli?
Yes.
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 Okay. I think now mnanipata, isn't it?
Yes.
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 Hello? I think now we can.
Hello.
Hello, I'm able to get you. Now, everybody is around. Can we give another like 2 minutes? I can see the team. Do we expect more? Or we can start off?
We are expecting more.
We are expecting more.
Yes.
So we can allow a few minutes. Ama, we can start off. So we are doing an alkane today. So we are now going to the preparation bit of alkane. So you get ready for that. We'll be able to move a little bit. The terms of engagement is very simple that, as Mr. Steve had said, that when you find there is something that you're not getting, you want me to repeat, you can simply unmute yourself and possibly we'll be able to hear you and I'll be able to do the necessary for you. So let me adjust myself so that you're able to see me. Okay, now I think we can start. Steve, we are expecting more. We can give like 2-3 minutes or?
Yes, let us give them around 5 minutes. Let me remind them.
Okay. Maybe somebody has a question from the previous topic that we are dealing. Maybe you can ask as we wait for the few elements that are just about to join.
Our lesson does not have a limit. We don't have time limit at all. We can go even more than 2 hours, the way right.
No, we'll just be able to do something that is will be able to enable them to digest. Then from there we can see what to do. Okay. Accordingly. Yeah, of course we'll be able to finish up with the preparation, the physical properties. Because if we cover much within a very short time, they may not be able to digest. I could see the other time the nomenclature, they were able to capture very well. It was very good.
Yes.
Did you get the number for that guy? I've never got it. The guy who was about to get some reward.
Yes, but I realized that he was a teacher.
Oh, that was a teacher?
Yes.
Ah, if that is a teacher, then now we may not be able to do much. Eliminate the time to not answer the question, to wait for the students first. That can be able to share.
I can see some are coming. Okay.
Yes.
Today, we are also happy to report discharge 51 from various health facilities, bringing our total number of recoveries to 643.
Who is that?
And for these recoveries,
Yeah, man. Somebody's. Okay, I'm asking either somebody has a question to the previous topic or any question related to chemistry. I can still be able to answer. Somebody has a question? Who is that now?
I have a question.
Yes, yes, Lisa.
I have a suggestion. You should first mute everyone so that you can, when you communicate, no interference is heard, because there are people speaking on background, so we can't hear you clearly.
Okay, good. Steve, you know the necessary about the muting so that we can be able to see what to do.
Okay, I'll do that.
Sustainable much threat will it pose to fellow Kenyans, because someone
Alliance.
Ezekiel Chama. Si kamera.
Manijaribu kudownload kitu.
Seems there are so many guests who are entering or rather than muting themselves, maybe, or is what?
Hey, I'm just admitting them. You can just continue. You can just share the screen if you have something to share.
I can just share this. I'm just wondering why my mic is not working. It would have been the best to capture me. Steve, are you able to get me now?
Yes, I'm getting you.
And in one of the funerals during wedding, we observed that over 300 people have attended that.
Camping. Okay, I'm camping. This is a community organization. I'm just from and Congo right now. I was creating awareness within those people. And there is a big problem now, especially today in 2 hours. Community organization. And I'm just from Kibira and Congo right now. Near the police.
Okay, Steve, please can you mute the guy on the other side? We are not able to go.
Ezekiel, if I mute you, kindly don't unmute yourself. You are bringing a disturbance. We don't want the news from Nairobi. We are in a class.
Okay. I think there is problem on your side. Student, are you able to hear me?
No.
Yes.
Yes.
Are you able to get me?
Yes.
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 Are you able to see the screen?
Yes.
Okay, good. I'm just wondering because there's a lot of distorted voice from Steve, so I'm just wondering. Yeah? You're able to get me, Steve?
Yes, I'm able to get you.
Good. At least now we have no disruption. Now, because there is a student who is asking a question there, I can be able to see from the chat. And the student is asking that what happens when dry ammonia is added to nichrome wire? First of all, there is a question there, and you need to know the equation that is involved. So in that kind of a scenario, when there must be heat in that reaction to occur. So when you heat ammonia in the presence of nichrome wire,
and in presence of air, I understand what you are trying to ask, is that the nichrome wire acts as a catalyst. So it catalyzes the reaction to produce nitrogen 2 oxide plus water. So the equation is NH3 plus oxygen gas you can write is equal to NO, that is nitrogen 2 oxide plus water. The balanced equation is as follows. There are 4 moles of ammonia, 5 moles of oxygen, or 4 moles of nitrogen 2 oxide, and 6 moles of water in that particular question. So I want to believe, Josephat Odicho, you have been able to understand that particular question. I'm very sure that you're trying to ask the question whereby there is presence of air. So in that kind of a scenario, we are going to lesson 2 from the previous.
I have a question.
Yes.
Here.
Yeah.
In the question paper,
what is it? I'm not able to get you. So, anybody who has asked whoever was asking the question, because I was not able to hear him. Steve.
Yes.
I have lost. There was a student who was asking a question, but I've lost the kid.
Yes.
So,
it was not clear.
Yeah. So.
Yes, sir.
Want to say, yes.
Can you hear me? Can you hear me?
Yes, I can hear you now.
And
Uliza swali.
Now the next question is, write the formula of the complex when excess ammonia gas is passed through a solution containing zinc 2 ions.
Umeona sasa nimekupasha uhondo.
Okay, good. I get your question. I understand there might be some network issues.
Can you please mute
that? Soon na pia nyinyi. Tena na nyinyi.
Steve, can you mute whoever is talking?
Who is that? Don't you class kindly.
We can be able to see those guys who have not muted themselves. We have Nugare, okay, we have Josephat, Faida Chola. Those guys are not.
Please see if I can find a point. So Josephat is asking a question.
A question. Now we'll leave the swali. You are the guy who was asking the question about the copper. Eh? Okay, I was muted, but I'm no longer muted. So Josephat, very good. Yeah. You have asked a question like, Ann Dinda, you are still not mute. Ann, please, can you mute yourself? Yes. Faida Chola and Ezekiel Mwania again. Ezekiel Mwania, unless you're asking a question. Because we are really having a lot of disturbance from those guys. Now, I want to ask a question, to answer the question. Answer the question by that student who was saying that, okay, good. I want to believe you're able to hear me. I was also under mute, but I think now it's okay. You're able to hear me?
Yes.
Steve?
Yes.
Okay, good. Now, There's a question. There's a student who has asked a question about the zinc reacting with excess of that, and when you pass ammonia gas through a solution containing zinc ion, first of all, the solution will the water in the solution will now convert the dry ammonia into aqueous, and the ammonia will now react with zinc to form the tetraamine zinc 2 ions. What is the formula of that? Zn NH3 into bracket 4. Zn, that is zinc, into bracket NH3 into bracket 4. Then you put a larger bracket to enclose everything, and you give a charge of positive 2. That is for just part of data. You can, yes, you can combine all the other questions.
Then
using a board by the time we finish. So now we can start. I'll be able to have some sessions for question and answer possibly for that. So our topic of today is alkanes, and today we are dealing with preparation of alkanes and the physical properties. So that is simply the profile is not important in that particular lesson. So the specific objectives. By the end of the lesson today, the learner, you are the one. If the learner is Kelly, Melissa, Josport Odicho, or Ezekiel Mutua, you should be able to describe the laboratory preparation of methane and ethane. That's what the syllabus said. Describe the physical and the chemical properties of alkane. Remember, according to the syllabus, you have 18 gases. You are supposed to be able to know how to prepare 18 gases. In Form 1, there are only 2, hydrogen and oxygen. Form 2, 2, carbon 2 oxide and carbon 4 oxide. Form 3 are the bulk of the 14 gases that under the syllabus. You should be able to understand. And those regards, like now you see in organic chemistry, we already have 4. Methane and ethane, ethene and ethine. In nitrogen, you expect to know 5. Those are already 9, plus the 4 in organic. That takes you to around 13 gases. We are only remaining with 4. So sulfur 3, sulfur 4 oxide, sulfur 6, hydrogen sulfide. Those are already 15. Those are already 16. Then you go to chlorine, whereby you're going to have chlorine gas and hydrogen chloride. So that's the most important thing. We need to be able to describe the physical. Mostly today we are going to do the physical properties of alkanes. So we go with the laboratory preparation of alkanes. I want to believe you are able to see there. And you capture every bit. Very important. Number 1 is in a school laboratory, alkanes are prepared. Alkanes are prepared by heating a mixture of sodium alkanoate with soda lime. And soda lime is a mixture of sodium hydroxide with calcium oxide to get the corresponding alkane like that. So we are saying in a school laboratory, alkanes are prepared by heating a mixture of sodium alkanoate plus soda lime. In reality, the only reagent that is reacting there is sodium hydroxide, but we usually mix it with calcium oxide. So why do we need to mix it with calcium oxide? But the only thing that is reacting there is sodium hydroxide. The role of the calcium oxide is to keep the deliquescent sodium hydroxide dry. The role of the calcium oxide is to keep the deliquescent sodium hydroxide dry. Very important for you to be able to understand that. So in a school laboratory, alkanes are prepared by heating a mixture of sodium alkanoids with soda lime, that is sodium hydroxide mixed with calcium oxide, to get the corresponding alkane less one carbon atom. The role of the calcium oxide is to keep the deliquescent sodium hydroxide dry. Be guided accordingly. So now, let's look at the chemical equations. So that's the first chemical equation. That's the first chemical equation. I want to try to minimize that. I still want to believe you're able to hear me and you're able to see me. Mr. Steve?
I'm able to hear you very well and see the screen as well.
And see the screen, eh?
Yes.
Good. So, yeah, because that's the control. So with the chemical reaction there, we are reacting sodium alkanoids with soda lime. The component of soda lime that we are reacting there is only the sodium hydroxide. Although we say soda lime is a mixture of sodium hydroxide and calcium oxide. So when you get here the corresponding alkane, less one carbon atom. I want you to get that point. We don't really get the corresponding alkane, but it's the corresponding less one carbon atom. What we mean by corresponding is this. Sorry. So if the alkanoid is sodium propanoid, the corresponding alkane from the propanoid should have been propane, but we get less one carbon. So if you are using propanoid, you're going to get ethane because it has less one carbon atom. Why? Look at this equation here. And alkanoid has a formula of CN H2N plus 1. Then we have the carboxyl group and the sodium. So this is an alkyl group, which is CN H2N plus 1. So when we are now forming alkane, this is what happens. You get the formula of this, the alkyl group, the alkyl components making up the sodium alkanoid. This alkyl carbonate, which is the formula is CN H2N plus 1, you are going to add the hydrogen from the sodium hydroxide, which now you'll be able to get CN 2N plus 2, which conforms to a formula of an alkane, then a sodium carbonate. So why are we getting the alkane with less one carbon atom? Because one of the carbon from the sodium alkanoid react with the sodium hydroxide to form the sodium carbonate. So that is where the one carbon atom disappears to. So get that one very simple. We are getting the alkyl carbonate. Somebody is interfering with the screen. We are getting the alkyl carbonate. We are getting the alkyl carbonate, reacting it with the hydrogen from the sodium hydroxide to get the alkane plus sodium carbonate. Look at that. So here we are using sodium ethanoate. The alkyl component of the sodium ethanoate is methyl. So the methyl, you see I've written it with red, will combine now with the hydrogen from the sodium hydroxide to get the CH4. Then the NaO of the sodium hydroxide combined with the alkanoid part, which I've drawn with the green, with the blue to form the sodium carbonate. And that's why I've said, although here the alkanoid has 2 carbon atoms, the alkane will have 1 carbon atom because one of the carbon atoms from the alkanoid will combine to form the sodium carbonate. Let's look at that. The most common blunder with students, if you see you are preparing an alkane and you are using sodium alkanoids, many of the students, if you are using ethanoid, they say the gas is methane, which should have been methane. Look at this. We want to get ethane, so we must use sodium propanoate. We must use sodium propanoate. The alkyl component is CH3CH2, reacting with this to form the alkane. So you can be able to see the hydrogen from here combined with the hydrogen from here to get CH3, which is the methane, then plus sodium carbonate. It is as simple as that. The preparation of this thing requires heat. We can now go to the diagrammatic preparation of methane. The lab preparation of methane, look at that. That's the diagram. We have already done the equation. We can have the diagram. We can have the diagram there. So that is the sodium ethanoate. We are reacting with it to form methane plus sodium carbonate. You can be able to see the diagram, a very beautiful diagram there. We're having sodium ethanoate plus soda lime to collect methane. The gas is being collected over water because it is slightly soluble in water. And I want you to get this clearly. If you're told why methane is collected over water, you the answer is water. They are slightly soluble in water, except hydrogen, which is completely insoluble in water. So the only gas that is completely insoluble in water is hydrogen gas. So for all the other gases that you have seen and they're collected over water, the answer is they are slightly soluble in water. Number two, you can be asked to give the importance. What? Yes?
There is somebody raising the hand.
This?
Somebody raising his hand called Ali. I don't know whether he has a problem or no.
Okay, let him talk. Ali has an issue?
Sir.
Yes.
Sir.
Yes.
Yes, sir. I had an issue, but I have understand. I'm somehow. Yes, I've understood. I was asking what type of reaction does that occur, but I have understand we have not reached at that point.
The type of reaction, eh?
Yes. When you take methane, then you react with excess chlorine gas.
Oh, yeah, I'm going to give you the name of that reaction.
Okay.
I'll not give it, but I'll give it. Very magnetic. Now in that kind of a reaction, if you are preparing a day,
also Josephat from St. Charles.
Josephat, yes. Josephat, yes. Uliza swali.
Continue, mwalimu.
Good. If you want to prepare ethane, the same setup will be there. Only that you're going to get the reagent, which is sodium propanoate. So, but this reaction, if you're told the condition, it requires heat. Look at that now. The laboratory preparation of ethane gas. Ethane gas is prepared by reacting sodium propanoate. I've said if you want to get ethane, you have to use an sodium alkanoate with the 3 carbon atoms, and that becomes sodium propanoate. You are reacting with the sodium hydroxide to get ethane plus sodium carbonate, and the reaction requires heat. And remember, we said here we are using soda lime, which is a mixture of sodium hydroxide plus calcium oxide to get the corresponding alkane here. There's 1 carbon atom. So I want to give some issues of concern. Somebody had asked, that is Ali. This kind of reaction is called decarboxylation. This type of reaction is called decarboxylation. The spelling for decarboxylation is as follows. DE, decarboxylation is DECARBOXYLATION, decarboxylation. So this kind of a reaction is called decarboxylation. because we are simply removing the carboxyl group of the alkanoate. Remember, the alkanoate are the carboxylate group. So that is why we are calling it decarboxylation, because the product now we are removing the carboxyl group from there and we are remaining with, we are now combining the alkyl group with the hydrogen there. So the name of that kind of reaction is called decarboxylation. Ali, you can unmute Ali so that you can say whether that is what you wanted. Ali, is okay?
Yes, I've understand, but that was not the actual answer I needed. I was asking you.
Yeah.
When you take methane gas, then you react with excess chlorine. That type of reaction that is undergone by that methane.
Yeah,
so
that's a different question, and that is substitution.
Yes.
I can simply ask you, that is substitution.
Oh, okay, yes, I was asking that, sir.
Okay.
I've understood.
Precautions in preparation of gas, there are always precautions. And the precaution there is the delivery tube should be removed immediately heating is over to prevent sucking back of the water to the hot flask. B1, I want to take you back to the question. Look at that. If before you stop eating, there is a precaution you take here. You withdraw this delivery tube before eating is stopped. Why? Because gases once heated. So if you are eating here, the gas that is inside the tube here, or rather the test tube, will be expanded. So if you cool, if you allow the apparatus to cool, the gas will now compress, will now contract, reducing in volume. And this will create a partial vacuum. This will create a partial vacuum within this particular tube. And that will now cause the water to suck back to replace the vacuum here. And this will cause breakage. So it is not just this, but for any gas that is collected over water and heating is involved, the precaution before heating is stopped is to withdraw the delivery tube before heating is stopped. That is the same precaution you're going to use for preparation of oxygen through heating potassium manganese 7, heating oxygen by heating potassium chlorate, potassium nitrate, preparation of reaction of method with steam, because heating is involved. You always have to withdraw the delivery tube before you stop eating to prevent sucking back. It is something that you can use it for any. Have we understood that, students? So you need to know what are the general. The delivery tube should always be removed immediately eating is over to prevent sucking back. That is a general precaution that is used for any gas that involves heating. Very good. Properties of alkanes. Properties of alkanes, and that we are looking at the physical properties. So we are having the whatever there, the general formula. This is methane. This is ethane. This is propane. You can look at the boiling point in Kelvin scale. You can look at the density. You can look at the state and room temperature. I just want to give you something that is very, very important, and that is now you can look at the boiling point and melting points, and the densities are also increasing with the increase in carbon atom. There is a common blunder that some of you students will say, and the student here will say, the melting point and boiling point increase down the group. That is complete nonsense. That is a misnomer as far as chemistry is concerned, because of one scenario. There is no group here. Down the group, you say the melting point and the boiling point. The melting point and the boiling point increase with increase. The melting point and boiling point increase with increase in carbon chain. due to increase in molecular size, which increases the number of van der Waals forces. So it is the same even for the other. We can look at the
Excuse me,
pentane.
teacher.
Yes,
Please repeat
Please,
what I've
teacher,
said.
pardon.
Which one?
Pardon. How you should explain the point on how the boiling points increases down the homologous series.
Good, Melissa. I said, don't say they increase down the homologous area. You say the melting point and boiling point increase. I'm going to give you the point. Remember, I'll be able to give it. I'm just explaining this, but there are points that I've captured there. The melting point and boiling point increase with increase in the carbon chain. With increase in the number of carbon atoms in the chain. So this is due to increase in the size of the molecule, which increases the number of van der Waals forces. The number of van der Waals forces, or rather the strength of van der Waals forces. But now, most of the books they have talked about the strength, but really we simply have the increase in number of van der Waals forces, not really the strength. Although we mark any strength or number of van der Waals forces, any scores. Melissa, is that okay?
Yes. Thank you.
I'm going to give that. So the other thing is the density due to increase in molecular mass. Remember, mass is directly proportional to density. Rather, density is directly proportional to mass. The higher the molecular mass, the higher the density. That's why you're going to find that kind of a scenario. So we look at the physical state of the elements. I just want to give you the differences. Alkanes are colorless gases, liquid and solid. Let's look at how the change in physical state will change. I'm now explaining that. Now the capturing is there. You can take a screenshot. I'll also be able to share the notes. So methane to butane, the state at room temperature is a gas. That is simply all carbon atoms between alkane with carbon atom 1 to carbon atom 4. They are normally gases at room temperature. Then carbon atom 5 to carbon atom 16. That is between the liquid room temperature. Then above 17 carbon atom, that is heptadecanes. Heptadecanes upwards. The heptadecane upwards will be solid at room temperature. That is simply something that you can be able to know. In fact, I can tell you that's why you looking at our table, whereby we're having this from methane, ethane, propane, even to butane. They are normally gases at room temperature. But down from pentane, pentane, hexane, heptane, those are liquids. Simply carbon 1 to carbon 4. Any alkane with 1 carbon atom all the way to 4 carbon atoms, those are gases at room temperature. From 5 carbon atom to 16 carbon atom, that is from pentane to hexadecane. Those are liquid at room temperature. And finally, we have from heptadecane, 7 carbon atoms, or the 17 carbon atoms or upwards. Those are solid at room temperature. Now, we'll be able to explain more of that. The density, the higher the molecular mass, the higher the density.
Sorry, sir, there is somebody who has
I remember the state at room temperature and the melting point or boiling point. That point, automatically it's going to be a solid at room temperature. A substance that has a very high melting point, it will be a solid at room temperature. A substance that is that have a very low melting point will be a gas at room temperature. Very important for you to be able to understand.
Yes, Mwalimu.
Yes.
There is some two people carrying their hands. That is Camilla and Howard Dean.
Let them ask their question. You can unmute them.
Okay, Dean.
They can unmute themselves. Then they.
when you're asked about the gas, why is it a gas? What are you supposed to say? Like, why is it?
Why do you are told to?
Gas? Like, why is it being considered a gas? What are you supposed to say?
Camila, come back again. Pardon.
I meant, like, let's say when you're asked what is why is it being a gas? Why is it considered a gas and not a liquid?
Okay, I think let me get it right. Are you asking if the examiner gives you a table and it tells you which substance is a gas at room temperature, what you're supposed to answer?
Yeah,
is that the question?
Yeah, something of the
Camila.
sort. Yes. Yes.
You ask, in case you're given a table and then you're given substance ABC and then you're told which of those substances is a gas at room temperature or at a particular temperature. Are you supposed to answer that particular question?
Yeah.
Good, very magnetic. Now, that's a very simple question. I'm going to answer for all of them, the way they can be asked. You can be given a list of compounds. Then you are told, select a substance that is a gas at room temperature. First of all, you have to know room temperature is 25 degrees Celsius or 298 Kelvin. Are we together, Camila?
Yes.
So after knowing that, for a substance to be a gas at a particular temperature, its boiling point must be below that temperature. For a substance to be a gas at a particular temperature, its boiling point should be below the room temperature. Like, look here. The room temperature here, the room temperature is 25 degrees Celsius. Converted to Kelvin scale, that will be 298. So you look at that, look now here. Look at all these substances. They are gases. Because their room temperature is below, their boiling point is below 298, meaning that by the time you reach 298 Kelvin, the substance will have changed from a liquid to a gas. That is one of the issues. For a substance to be a liquid, a gas at a particular temperature, somebody is disturbing us. For a substance to be a gas at a particular temperature, its boiling point should be below the room temperature, which is 25. Like, for example, you can be asked which substance there is a gas at room temperature. Then you can say methane because their boiling point is below 298 Kelvin, or rather, is below 25 degrees Celsius. Now let's look for a substance. A substance should be a liquid at a particular temperature. Here you consider two things. For a substance to be a liquid at a particular temperature, its melting point, like for example, which substance there is a liquid at room temperature? Room temperature is 298 Kelvin. The melting point should be below the room temperature, meaning that by the time you reach the room temperature, it must have melted. It must have changed from solid to liquid. But the boiling point should be above the room temperature. That it should not have boiled. So there are two things. Look at pentane. The melting point is below 298, but the boiling point is above 298. So meaning that it's a liquid at a particular temperature. So, and finally, you can see for all these substances, their melting point is below 298. Their melting point is below 298, but their boiling point is above 298. Then we'll be asked, another one is, which substance is a solid at room temperature? You only look at one thing. the melting point. The melting point should be above the room temperature. Like sodium chloride, other melting point of about, I think, around 800. Sodium chloride, 800 degrees Celsius. So its melting point is above the room temperature, above room. Therefore, it is a solid at a particular temperature. So for a substance to be a solid at a particular temperature, its melting point should be above that particular temperature. For a substance to be a liquid at particular temperature, its melting point should be below that temperature, and boiling point should be above that temperature. But for something to be a gas, you simply consider the boiling point, which should be below that particular temperature. Is it Camila? I think you've got that one right.
Yeah, I've understood. Thank you.
Umepata?
Yeah, nimeelewa.
Camila.
Nimeelewa. Thank you.
Camila.
Yes, I've understood.
Camila.
Sure, I've understood.
Yes, mwalimu. Mwalimu.
Yes, niko hapa. Mnaniona?
Nakuona vizuri. She has said that she has understood.
Okay, yeah, I think there was a problem. I could not get and then all of a sudden I got lost. I think there was something with connection issues. So let me get back to where I was.
And also there is a word dealing with the question.
Yes.
Dean,
Okay.
you can answer
Yes,
your question.
Okay.
You can ask your question.
Yeah.
I have there's someone who asked a question here.
Yeah.
Josephat asked, in the last screen you used sodium propanoate to get ethane.
Yeah.
Now, and you never asked him what about getting propane. I thought maybe it was sodium butanoate, but
Yeah.
that one is my guesswork. So please, could you help us?
Very magnetic. Now, very good students. You're asking a very good question. Now, from what you have learned, tumesema, niongee Kiswahili sasa. Unajua watu wa Mombasa mnapenda Kiswahili. Kama unataka kutengeneza butane, if you want to get ethane, you have to use an alkanoate with more than 2 carbon atoms by 1. So if you want ethane has 2 carbon atoms. So the alkanoate will have how many carbon atoms? 3. And the name becomes propanoate. Remember when I started teaching you the first lesson, I told you the names of organic compounds are derived from the Greek roots. So if you want to get propane, you have to use an alkanoate with 4 carbon atoms, which becomes what? Sodium what? Butanoate. And we can get even...
You are too fast.
Good. We are just reviewing. Let me get back again. Tumesema hivi, if you want to get an alkane, you use an alkanoate with more than 1 carbon atom as the corresponding alkane you want to prepare. So if you want to get an alkane with 1 carbon atom, you are going to use an alkanoate with 2 carbon atoms. And that is why when we were preparing methane, and I think I can still go back to this. That's why when we were preparing methane, we used an alkanoate with 2 carbon atoms, which becomes sodium ethanoate. Hapo tuko sawa, eh? Are we together there?
Yes.
Good.
Yes.
If you want to get ethane, you use a sodium alkanoate with more than, this one has 2 carbon atoms. So plus 1, you have to use an alkanoate with the 3 carbon atoms. And from the nomenclature, if an organic compound has 3 carbon atoms, its name should have the word prop. So the name becomes sodium propanoate. What if you want to get propane, which are 3 carbon atoms? you have to use an alkanoate with more than 3 carbon atoms by 1. You simply add 3 plus 1, you get 4. So what is the name of the metal alkanoate with 4 carbon atoms? It's going to be called what?
Sodium butanoate.
Butanoate. Very good. I want now to pick something else which is very even far, like an alkane with 7 carbon atoms is called an heptane. So if you want to get heptane, what will be the name of the salt?
Sodium octanoate.
Sodium octanoate. Very good. If you want to get pentane, what are you supposed to use? Pentane. You are going to use what? Sodium hexanoate. Very magnetic. I think now that one is very much good. Hiyo umeelewa kabisa. Now, just know that the syllabus will only require you to prepare methane and hexane, but it's good you have asked that. So let's now go to the reasoning. Somebody was asking this. You can read now. The melting point and boiling point increase as the carbon chain increases. This is because of increase in number, or rather strength of van der Waals forces with the increase in molecular mass, stroke molecular size. So you can capture that. You talk about the melting by boiling point of alkanes will increase as the carbon chain increase. This is because of the increase in number, stroke the strength of van der Waals forces with the increase in molecular mass. So I want you to get this once and for all. For molecular compounds, like organic compounds are molecular compounds. And this will apply to alkanes, to alkanes, to alkynes, to alkanols, and alkanoic acids. As the carbon chain increases, as the size of the molecule increases, there will be increase in number, rather the strength of van der Waals forces. And that is why for all organic compounds, the melting point and boiling point will always increase as the carbon chain increases. Very important for you to be able to capture that. Very important. Tuko salama, eh? You're able to get that?
Yes.
Good.
Yes.
Now, okay. And remember, before I continue, this is also the same thing for why when you're talking about, you remember the halogens in periodic table, the halogens. Eh? How does the melting point of fluorine, chlorine, bromine, iodine, how does it vary down the group? Does it increase or decrease?
Increase.
Why? Why do they increase? Why do they increase? Why do the melting point and boiling point of halogens increase down the group? Somebody to try?
As there?
Why does the melting point and boiling point of halogens increase down the group?
Increase in size of the molecules down the group.
Yeah, increase the what?
There is an increase.
Sir.
Yeah.
As we go down the group, the size of the molecule increases, and even the electron arrangement also increases. Therefore, making the melting point to be higher. Therefore, for the break.
Okay, good. Now we are looking at this. Very correct, but avoid abusing some things. Eh? Whenever you are answering any question on melting point or boiling point, your answer must invoke the concept of structure and bonding. Look at my answer here. You're able to see my screen, isn't it? You're able to see my screen, yes?
Yes.
Good.
Yes.
So look at this.
Yes.
In my answer, there is the number of van der Waals. I have invoked the concept of bonding. It must be captured. So even when you're giving about the halogens, you say the melting point and boiling point of halogens increase down the group, because as you move down the group, there is increase in the size of the molecule, which increases the number or the strength of the van der Waals forces. Mnashika?
Ndio.
Are you getting it? Yes, that's how you answer the question. It is also the same scenario whereby you are going to be asked why bromine is a liquid while chlorine is a gas at room temperature. That question is simply asking you to tell us why, if something is a liquid and another one is a gas, which one has a higher boiling point than the other? The solid or the liquid or the gas?
Liquid.
Yes, so in short, when the examiner tells you why chlorine is a gas while bromine is a liquid, he's simply telling you to explain why, to tell him why the bromine has a higher boiling point than chlorine. And the answer you're going to say, both chlorine and bromine have simple molecular structure, but the bromine molecule is larger than the chlorine molecule. Therefore, bromine has more, or rather it has stronger van der Waals forces than chlorine. Therefore, it has a higher boiling point. It's also the same scenario that you're going to be asked why pentane is a liquid while ethane or propane is a gas at room temperature. The answer that you are supposed to give there is butane has a larger molecule than pentane has a larger molecule than ethane. Therefore, it has more, or rather, it has stronger van der Waals forces than ethane. Make sure that when the examiner brings about the issues of a substance is a liquid, another one is a gas, you are simply being asked to explain why this one has a larger, has a higher molecule than the other, or rather, why one has more, has a higher boiling point than the other. Get this right, that there are two ways I can ask you a question on this. Why? I can give you the melting point and boiling point, then I tell you to explain why pentane has a higher boiling point than propane or than ethane. Or rather, I can give you their physical state at a particular temperature, that pentane and hexane are liquids, while ethane and propane are gases at room temperature. Then I tell you to explain what is the expected explanation from the examiner's point of view. Then you're going to tell us now hexane and pentane they have a higher molecular size than propane and ethane. Therefore, they have a stronger, or rather they have more van der Waals forces. The hexane and pentane, they have more van der Waals forces than ethane and propane. So make sure that when you're taught to compare the different state symbols, you have to invoke the concept of molecular size and therefore the van der Waals forces. So properties of alkanes, we're still in physical properties. They are insoluble in water, but very soluble in organic solvent. But I say don't use the insoluble, use the slightly soluble in water. There are slightly soluble in water, but soluble in organic solvents like tetrachloromethane, like or methyl benzene. The density of straight chain alkanes increase in carbon chain is the molecular mass in yes?
There is a question from Josephat and Janet.
Good. Let me hear them.
Sir.
Yes.
Can you please repeat in the part where you have said that one should explain why chlorine is a gas and
bromine is a liquid.
the other one is a liquid in
When you are taught to explain why bromine is a liquid, while chlorine as a gas at a particular temperature, you have to invoke the concept of structure and bonding. And you are supposed to answer it this way. I don't know why there is an echo somewhere. I don't know why. You're getting me, Joseph?
Yes, I'm getting you, sir.
Okay, good. So when you're taught to explain why bromine is a liquid, while chlorine is a gas, you simply being asked to explain why bromine has a higher boiling point than chlorine. That's what the examiner is asking you. Because if something is a liquid, the other one is a gas at the same temperature, it means the one that is a liquid has a higher boiling point than the one that is a gas. Therefore, you explain it this way, that bromine has a larger molecular size than chlorine. Tick point number one. Therefore, bromine has stronger, or rather more van der Waals forces than chlorine. And therefore, bromine has a higher boiling point than chlorine. So the answer is as follows. Bromine has a higher molecular size than chlorine. Therefore, it has more, or rather it has stronger van der Waals forces than chlorine gas. And therefore, it has a higher boiling point than chlorine. Got it right, Josephat?
Yes, perfectly understood.
Good, very magnetic. We can be able to continue. So here we are saying, here we use the word slightly. Let us use the word slightly instead of insoluble. So use slightly soluble. Cancel that and replace it with slightly soluble in water to be more suitable than that, than just saying they are insoluble. The density of straight like chain alkanes increase in carbon chain as the molecular mass increases. Again, that is another point. The higher the molecular mass, the higher the density. We're still in properties, the physical properties of alkanes. We're still in the physical properties of alkanes, and we are getting combustion. We are looking at that. No, that's okay, good. Physical properties. Combustion, we are not doing it now. Combustion, but I can just say it. We'll continue with the other. I can just, with the chemical properties, we can look at, I'll be able to organize for a practical, where by the time we're finishing, I'll be able to organize a practical setup. But that one we'll talk with Mr. Steve, but I'll be able to organize this one. Is that now, this one, they'll burn with a blue flame. They burn with a blue flame. The alkanes burn with a blue flame, so you can be able to capture that. They burn with a blue flame. Let me see if I can be able to show, to demonstrate one. Let me see. Just give me a few minutes. You can put the speaker view. I want to stop here. Are you able to see me? Mnaniona kweli? Let me organize to see whether I can be able to get some a demonstration of how they burn.
Hi guys, welcome to P at Home Workout. Mazoezi ambayo itakusaidia pale pale mtaani pale kwa nyumba yako.
Joki, you had a question? Joki, did you have a question?
Can you be able to see the flame?
Yes.
Excuse, you're able to see it?
Yes.
Which color? A little bit, the yellow flame, but you can see the little bit, most of it is very, very, it is very what? It is more of a bluish. Are you together?
Yes.
Or it is confusing you? So
No.
this
No.
one is not there is a little bit some interruption, but you can look at just look at the base. Not that I've just put a lot of the alkane. That's why it is bringing the yellow color. But at the end, you'll be able to see the way you'll be able to see that. It should burn with a blue, purely blue flame, not yellow. But I'll show you how yellow burns. I'll be able to show you. So yeah, look at the last bit, the lower part, like now. This is now the one that is able to show you how that one burns. But it's simply because I'm doing a lot of, but this is our blue flame. You see now, if you're able to see from that particular end, that is how our blue flame should be able to be seen. It should not be very, very yellow. And that's how alkanes will burn with a little bit. Able to get. Okay, look at the difference now. Are you seeing this? Are you seeing this?
Yes.
This one is purely yellow, yellow, yellow. So that is what we expect. This is now the opposite of it. And you're going to go to to alkenes and alkynes, they're going to burn with a yellow sooty flame. The other one should be blue, as I was able to show.
Oh.
So now I have said I was demonstrating that for those in Form 4, that is that you're going to be able to see. That you see that one is burning the blue flame, the other one is the yellow flame. Be able to see. I'm seeing them chant there. Raise up your hand so that you can see you. Okay, you have seen a question that is there is a question. There's a student who is asking a student. I just want looking at the chat.
Bedroom.
Good. I've seen somebody is asking why. There's somebody who's asking why methane is more soluble than butane, and the answer is as follows: that now, as you move down the group, but not as you move down the group, as the molecular mass increases, the solubility decreases, because as the size of the molecule increases, the compound becomes more molecular. It becomes more non-polar, because the higher the molecular mass, the more molecular that compound is. So it becomes, the solubility decreases because molecular substances are insoluble in water. So the higher the molecular mass, the more, the higher the molecular mass of a compound, the more molecular that compound is, and the more non-polar that compound is, because remember, molecular substances are non-polar. If the compound, the size of the molecule increases, the compound becomes more non-polar. And I think that one I'm very, very clear. That was somebody has no name. He's just calling himself. We were looking at that. The guys in Form 4. How many guys are in Form 4 there?
Yes.
You have Form 4 there? Yeah. So remember, when we'll be talking about that, when a compound burns the blue flame, you say that the compound is unsaturated. You say double bond, triple bond absent. When a compound burns the yellow flame of a yellow flame, they did double bond, triple bond present. So that's whatever I was demonstrating is very much important for you. Let's look at the final part. And we say that alkanes burn with a non-sooty flame is there to form carbon 4 oxide and water. Low carbon alkanes, that is may burn with a flame, but long chain alkanes from pentane burn with a yellow flame. That pentane is petrol, but you just know that that high carbon content, or rather long chain alkanes, they also burn with a yellow flame, but normally low carbon content. Like when you go to, for those who are using a gas cooker and or kitchen gas cooker, the gases that are found in the gas cooker that we use is normally butane, propane, and that's why it burns the blue. But when you look at the hello.
Yes.
Hello. Hello.
Yes, I'm getting you, Mwalimu.
Okay, sorry, thank you. Like I not put my mic, so that I think there was a little bit of some problem. I've said alkanes burn with an unsooty flame in excess here to form carbon 4 oxide and water. Low carbon alkanes, that is methane to butane, will burn with a blue flame to form possibly carbon 4 oxide and water, and that is possibly from pentane. If you look at when you're using a kerosene step, kerosene stove. A kerosene is an alkane. It will burn with a yellow flame because it is a high carbon content alkane. So there lies the assignment. The diagram below used to prepare gas X in the laboratory, study it and answer the question that follow. So the question that follows there is, okay. Gas being collected over water.
It is slightly
less
soluble in water.
Good. What is the precaution that is needed?
You should remove the delivery tube before stopping heating.
Okay, good. When you are reacting this substance,
to prevent backflow.
The sucking back, good. When you are preparing methane, you mix sodium ethanoate with the dry sodium hydroxide. You are using sodium ethanoate with the dry sodium hydroxide. How is the sodium hydroxide kept dry in this experiment?
By adding calcium oxide.
Yes, that is how it is used to keep it dry. Very good. So that's it. You write the equation. I want to believe you can write the equation. Gadex, write an equation, describe two physical tests you can use to differentiate between pentane and hexane.
Mwalimu, we have a question from Neon.
The physical state. Yeah?
We have a question from Neon Ray.
Just before I answer him, I think you can unmute some guys there. You can just mute them completely. Now, one use of gas X, which is methane. What is the one use of gas X? Is used as a what? Yeah?
Fuel, cooking gas or a lab gas.
It is used as a fuel. The same as cooking. First of all, used as a fuel, and that's why you can add in lab or other cooking, domestic cooking. What are the two physical properties that you can use to differentiate between pentane and hexane? Do you know how to answer that question?
Yeah. Pentane?
Pentane is a liquid while
both of them are liquid.
Melting point, then at a higher boiling point than pentane.
Good. That is the point. And this is how you describe it. Determine their boiling point. But you can say you can place the two liquids in a separate beakers, heat them, not their. Listen. Place the two liquids in a beaker, in separate beakers, heat them until it boils, not their boiling point. Hexane will boil at a higher temperature than pentane. Place the two liquids separately into separate beakers and heat them, not their boiling point. Hexane will boil at a higher temperature than pentane. That is one thing. Or determine their densities. Hexane has a higher density than pentane. That is physical properties. And physical properties about solubility, about melting point, or boiling point, about density. Those are physical properties. Let's look at the answer.
What about solubility?
Solubility, that one, because these things are insoluble. They are simply insoluble in water. So you cannot use their solubility. Solubility, you can use it when you're dealing with alkanodes. So for these things, just like now, you cannot talk about their physical state because both pentane and hexane are liquids. But if you're given ethane and pentane, you can say pentane is a liquid at room temperature and methane is a is a what? Is a gas at room temperature. But for this one, solubility, no, because these things are insoluble in water. They are almost insoluble. So when you say they're almost insoluble, you can't be able to get it right. Because when you add water to pentane or to hexane, remember pentane is petrol, by the way. When you add hexane, is also the same. When you add hexane or you add water to hexane or to pentane, there'll be now formation of what? That you'll be able to get 2 layers for each of them. So you can't be able to use it. One use of gas is used as a fuel. 2 physical properties determine their boiling point. Hexane has a higher boiling point than pentane. Determine their density, hexane has a higher density than pentane. But I'm saying you can describe it in a more magnetic manner, like place the 2 liquids into a separate beakers, heat until they boil. Hexane will boil at a higher temperature than pentane. And then this is assignment. You are given that homologous series, you can screenshot. Sorry. So the first one is you are told the organic
May you
compound.
repeat about the density?
Yeah. You're able to see the screen share, eh? You can even screen, yeah. Determine their densities. Hexane has a higher density than, not density point, simply density than pentane. That was a typo. Determine the density, the hexane has a higher density than pentane. Determine the boiling point. Hexane has a higher boiling point than pentane. But we are going to penalize you when you tell us boil them. You don't tell us boil them. That is not describing. The describing is determine their boiling point. Hexane has a higher boiling point than pentane. Don't say, don't just say hexane has a higher boiling point than pentane. That is not the what somebody is describing, huh? It is describe describe their boiling point. So the word is determined. Rather, place them in a beaker, eat them until they boil. Then you'll be able to get that. So that the assignment you can screenshot. Of course, I'm going to give it there. I will be able to give it when we'll be dealing with that. So the question that you're asking there, what is it?
Baraka.
Who is this sharing his screen?
Already started.
Who you? Okay. Yes. You know, when you try to share your screen, it automatically disassembles mine. So that one becomes very, very dangerous. So what is meant by the what is meant by the term homologous series? You know what? But what is an homologous series for most of you? Can you define that? What is an homologous series? Nobody has an idea how to define it.
I have an idea.
Yes.
I have an idea.
Yes. Yes. Say it.
Homologous series. It depends with the number of carbon atoms. They differ. They are
Shall I try?
Bottom to the high.
Yes, a good try. Somebody wanted to say, huh? Say it.
Okay, for me, I think it's a group of compounds with a similar chemical properties, chemical formulae, and they exhibit a gradual change in physical properties.
What is that?
Yes, pardon? Camila.
Who was answer that? Eh?
Camila.
Perfect.
Yeah.
So Camila, that's the perfect answer. That is the Homologous series refers to a group of organic compounds, or rather a group of compounds with similar chemical properties. This refers to a group of compounds with similar chemical properties. They can be represented by the same chemical formula. They can be represented by the same general formula. These are a group of compounds with the same chemical properties, same general formula, but they show a gradual change in their physical properties. These are a group of compounds with similar chemical properties. They can be represented by the same general formula, and they show a gradual change in their chemical properties. Period. As Camilla has put it, that is the most magnetic way of answering that particular question. As everybody understood that. Amepata hiyo, eh?
Yeah.
Yes. Good. Yes, good. Select one of the, okay. To which homologous series do those compounds belong?
Alkanes.
They belong to which homologous series? Alkanes. Select one hydrocarbon, that would be good. Select one hydrocarbon, that would be a liquid at room temperature. One which will be a liquid at room temperature. No, that one, there's none there. Sorry.
None.
Yes, because which is still an answer, because all those ones, their boiling point is above what? Above 298. So
298 degrees Celsius.
Good. That's the answer that you need to get that. Very well. So thank you very dangerous for your time. We have come to the end of our beautiful magnetic lesson today. You're very magnetic students. Anybody with a question?
Mwalim.
Yes.
Yes, I have a question here.
Mm-hmm.
When you were showing us the experiment about the alkanes property of burning, you said that it burns with a blue flame.
Yes.
And I assume you are in excess air. What about in a limited supply of air?
In a limited supply of air, of course, they're likely going to burn with a blue flame. They're going to burn with a yellow flame. That's it.
Yeah.
But you see, in an experimental setup, they are going to, they'll be able to, the presence of unburned carbon particles will always burn to produce will always produce the yellow flame. But in experimental setup that you're going to do in the exam, you're always going to burn it in excess there. But remember always that to just put it right there now, alkanes burn with a blue flame, while the other one will burn with a yellow flame, that's alkenes and alkynes. And always remember, when you burn alkane in excess there, you get carbon dioxide and water. But when you burn in limited supply of air, you get carbon dioxide and water. Another question?
Sir.
Yes.
I have a quiz, but it's outside the topic. Is it okay?
Yes, you can ask.
When zinc ions react with aqueous ammonia,
you
do form a product, but most of the time you're given the ionic equation, but what about the full equation? How is it supposed to be?
Like when you're reacting with what? With the
zinc ions with the aqueous ammonia, not ammonium hydroxide, the aqueous ammonia.
The aqueous ammonia. Remember, aqueous ammonia is a base. So when it dissolved in water, first of all, the first experiment, I think I better, let me see if I can be able to change. Let me try to get somewhere where there is a board. Let me change and I get my board so that we can be able to see. Please, Just give me a minute. I try to locate a board so that we can be able to. I can show you using a board, isn't it?
Yes.
There is somebody who has a question.
Okay. I want to believe you're able to see the board, isn't it? You're able to see the board?
Yeah.
So now.
Yes, we are able to see the board.
The board.
Yes, we are able.
Yes,
Okay,
we are
now.
able to see the board.
Okay, now that, let me explain the concept that is there. Let me explain the. So by that, we are looking at this. We are having this, what do you talk about? We are having the zinc or copper. We are having the zinc or copper ion. So the first thing is reacting with aqueous ammonia, but the aqueous ammonia, if it is aqueous ammonia, it has to be, we must have sodium, must have hydroxide ion from the base. So you get, the first thing is zinc hydroxide, that appears as a what? A white precipitate. Are you able to see it?
Yeah.
Yep.
Yes.
This appears, so you have to get this first.
Come on.
That's why you get a white PPT dropwise. Dropwise. But now, when now you add excess aqueous ammonia, now the zinc hydroxide now, the zinc hydroxide, which is a white precipitate, will react with aqueous ammonia. But now for the second experiment, you have to use the aqueous ammonia now will react like as an ammonia like this, not the ammonium hydroxide. So when you're getting this now, the white PPT, it has to start from here. The white precipitate will react with the aqueous ammonia to form zinc with 4 ammonia. 4 ammonia. Are you able to see it?
Yeah.
Are you seeing this side? With a charge of +2. And this is aqueous. Plus this one, you add plus 2 hydroxide ions. I don't know whether you're able to see this side. Are you able to see here?
Yeah.
So we're having zinc hydroxide plus aqueous ammonia, 4 of them. To get zinc combining with 4 ammonia ions, everything is aqueous here, and plus 2 hydroxide ions. And the equation is 1. That's how you're able to get it. In case you're getting the first one for formation, when you add aqueous ammonia dropwise, you get zinc hydroxide. When you add excess ammonia, now the zinc hydroxide, now the hydroxide ions are replaced by 4 ammonium ions. You get a tetraamine zinc 2 ion plus 2 hydroxide ion. I think that is what somebody was asking, whether if you want to write the whole equation, how you arrive at the tetraamine. That is how you get it. The name is tetraamine. Tetraamine. Zinc 2 ion. How much they get? They get 2 ion. Tetraamine. That's how you give it. That's how you give the name for that. And let me just, I hope you have got that. Umepata hiyo? Have you got that? So now let's.
Yes.
With sodium hydroxide, we have the aqueous ammonia for aluminium, whereby you're going to have, we have for aluminium, we have for lead, and we have for zinc with this. And then we have with aqueous ammonia. Which ion gives you a complex ion with aqueous ammonia? We have zinc and we have what? Copper. So I want to tell you this. Here we are I just want to show you how to get this zinc right. Tunatumia sodium hydroxide. So for all of them, whatever we are combining here is the OH, is the one that is now combining with this. For this, whatever is combining is the NH3. So for all of them, the combining component of the with the cation must be 4 of them. So kama hii ni hydroxyl itakuwa OH4. 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 It is going to combine with 4 hydroxide ions. Here it is combined with ammonia. NH, how many of them? Mnaona kweli?
Yes. Yes.
So,
Yeah.
kama ina combine sodium hydroxide, utachukua tu hiyo element, aluminium with 4OH, lead with 4OH, zinc with 4OH, and zinc it is combined with ammonia with 4 ammonia radical, and not ammonium NH4. It is NH3. The same with copper. Let's look at how to get the overall charge. Okay, what is the charge of hydroxide ion? What is the charge of hydroxide ions?
Negative.
-1.
Negative.
Na hivi ni ine. So, total charge of 4 hydroxide ions. What's the total charge?
Two.
-1 times 4. What are you getting?
-4.
You get negative.
Negative.
Aluminium has a charge of which? Positive what? Positive 3. So positive 3 plus -4. You get an overall charge of an overall charge of what? -1. Sasa mtu
Positive 2.
That is
Positive 2. Negative 2.
Zinc is positive what?
Positive 2.
-4, you get what?
-2.
-2.
-2. Zinc is positive 2. What is the charge of ammonia? It has a charge of what? 32.
Something like positive.
Positive 1.
0.
Yeah,
No.
positive 1.
You get the difference. Get the difference between NH4 plus and NH3. NH3 has no charge. The other charge of 0. Are you getting it right? Huh?
Mm-hmm.
Are you getting it? So it is 0 times 4, which is 0, plus 2. You get an overall charge of what?
2 positive.
Positive. And the same here. Copper is 2, then plus 0, you get positive 2. That's how you get the charge in there. So those are the only complex ions that you can be asked in the exam. And remember, zinc is the only cation which will form a white PPT soluble in excess ammonia and white PPT which is soluble in excess aluminium. So that's the content that you need to capture. Very, very important for you to make sure that we're able to get that. Mashika?
Yes.
Yeah, so that did. Sasa umeelewa mambo yote ya complex ions, eh? You have understood, eh? Yeah?
Yeah, hapo kwa complex ions.
Yeah.
Kwa copper.
Copper iko na nini?
Sasa ukiulizwa what's responsible for the deep blue color, unafaa kusema ni copper ama ni copper tetraamine ion.
The blue color is the copper, the copper 2 ions are the ones that are responsible for that.
And the deep blue?
Yeah? The blue color, both whether the deep blue or whether it's the deep blue or the pale blue precipitate, all of them it is for copper 2 ion. They are the ones that are responsible for the color, for the blue color or for the deep blue color. Very important for you to be able to talk that.
Thank you.
Mashika. Now we have come to the end of our lesson today. Please now let us now.
Please, may you repeat? Please, may you repeat?
Ati? I repeat what?
The explanation.
On the complex ions.
Yes.
So I've said sodium hydroxide are 3. The aluminium, we have the lead, we have the zinc. For all of them, they are combining, the combining radical, rather the combining radical should be 4. So aluminium should combine with 4 hydroxide ions, lead with 4 hydroxide ions, zinc with 4 hydroxide ions. When you come to ammonia, there are only 2 cations that forms a complex with ammonia. Zinc with 4 ammonia molecules, copper with 4 ammonia molecules. Let's look at getting the charges. Aluminium, the charge of aluminium is +2, +2. +2 minus 4. +2 minus 4. +3 minus 4, you get -1. +2 plus minus 4, you get -2. +2 minus 4, you get -2. For this one, this is +2, this is +2. The overall charge of ammonia is 0. So even if you multiply 0 times 5, you're still going to get 0. So this will be +2 plus 0. +2 plus 0, you get +2. So you can simply be able to remember that for both tetraamine zinc 2 ions and tetraamine copper 2 ions, they have a charge of +2 because of this scenario. That they're combining with ammonia, each one has a charge of 0. For the other one, we are combining with the hydroxide, 4 of them, each one has a charge of -2. So when you add the overall charge of the hydroxide plus the overall charge of the cation, you end up getting the overall charge. Mashika, you've got it right?
Yeah.
Umeshika magnetical. Tumesema the complex ions are only 5.
Yes.
Ni tano tu peke yake. That's the only thing that you can be asked. That's the only thing that you can be asked in the exam. Yeah?
We have understood magnetical.
Yes.
That's what I'm saying. Always ukipelekea kwa mtihani ujue hivyo. Vitu complex ions zinakuanga tu tano. There are only 5 that can be tested. Unaelewana?
Yes.
You got 3 of them, they are formed with sodium hydroxide.
Okay.
Na kila cation ina combine na hydroxide ngapi? 4. Aluminium iko na charge of +3. So it's very simple. Hata unaenda unakalala unaeka. The only thing that you can be asked. Usidanganya, hakuna kitu kingine utaiona. Those are the only complex ions you're going to find. So if you have a salt of aluminium and it is reacted with the excess sodium hydroxide, you're going to get this complex. Just 5 of them. And I think now I have cacamoniously and magnetically and illuminate and demystify this particular area of the complex. Yes.
There is a question. What Dinad has a question. I can see his hands up.
Yes.
Yes. What is how am I supposed to define a saturated hydrocarbon?
a saturated hydrocarbon, I'm going to give you both the definition of saturated and unsaturated. Very good. Carbon-carbon, a single carbon-to-carbon covalent bond. A single carbon-to-carbon covalent bond. That is a saturated. The other one is unsaturated hydrocarbon. This is a compound that contains a double or triple carbon to carbon covalent bond. A saturated is a compound that contains a single carbon to carbon. Don't be misguided by some fallacious misnomer in some of the publications whereby some will say carbon to hydrogen. It is single carbon to carbon covalent bond. Unsaturated will either contain double or triple carbon to carbon covalent bond. You have understood that?
Yes, we have understood magnetically.
Yes.
Okay, very good. So allow me to. Yeah?
I have.
Now, we have come to the end of the lesson today. Allow me to terminate the lesson in a very ruthless manner because we have already consumed 2 hours. So allow me to finish to complete the question at that point, or rather to complete the lesson. Engaging lessons, it is not very easy to survive, to have many.
So when is the next lesson?
You are looking forward for it. I'll be able to look at it. I can see what wengine sijui bando zilisha. We were somewhere around 30 something, and I can see now we are already 23. So make sure that you are there in the lesson. The other lesson now, I want to. Can I go directly to chemical properties of alkanes? No. Oh, yeah. You want me to start with preparation of alkanes? Anybody with a problem with the isomerism?
No.
So we can go to. We go straight to chemical properties, or we go to preparation of alkanes. How much one the two alkanes? We start with chemical. We first of all prepare. Prepare.
Yeah. We
Very
prepare.
Good. So we just continue. Yeah.
We prepare first.
Okay, good. Thank you, Stephen. I think we allow me to finish the lesson now. Steve, you can. I think we can call it a day. We can call it a day. Yeah. Yeah.
That's the next lesson. The next lesson.
We are going to tell you, Tom. Let me look at my calendar because I'm also having some other classes around. I think sometimes I'll also be able to invite you to my class by schedule from Alliance.
Yes.
Please do. Please do,
please do so. Please do so.
So I'll send you an invite. So otherwise, you are the most magnetic student in the whole wide world. Very good.
Yeah. Even you are the most magnetic teacher. You are the most magnetic
I don't usually give. I don't usually give a lesson of 2 hours. I normally go for 40 minutes.
You are the most magnetic teacher in the world.
Thank you, very dangerous. Thank you, very testimonial, and continuously by that compliment. So, thank you very much. So, Steve,
thank you, Tisha.
Yes?
Thank you.
Bye-bye.
Thank you
for the lesson.
Thank you for the lesson.
Bye. Bye, magnetic.
Bye, Camila.
Hello.
Camilla, guys.
Lisa, you're the most mag student.
Camilla, you're the most magnetic student. Lisa.